Okay, my friends. Two things. First coming out is old homework, so grab yours, pass on the rest if you don't mind. Mr. Stirrup, would you like to donate to my charity?
I got no money, man.
I ain't got no money.
All right. What was the page on homework last night? 17, 18?
I'll turn this in on whenever I get my
Roger. All right, page 17 and 18. What kind of questions might you have come across on 17 and 18? Oliver? Questions? Questions on page 17 and 18.
I have a question. It's problem 11.
Problem 11, you got it. All right. So problem number 11. Thank you for asking on that one. So we have this triangle. And they told us this is 2y plus 4. And they told us this is 4y minus 6. They didn't tell us what this blue side was, right? But they do tell us that the perimeter is, perimeter is equal to 7y minus 12. Is that okay? I like the hair. All right, so a couple things. Sophia, would you agree that if I were to add this side, and this side together, I should get the perimeter? But I only have two of the sides, right?
Yeah.
So let's just combine these together real quick, and that's going to get me 6y minus 2, right? So if I could take that 6y minus 2 and say, you know what? I'm going to subtract 6y from this. I'm going to add 2 to this. That's going to allow me to find that third side. So I get y minus 10 is my last side. That's it. What else would you like to see?
number 12.
You didn't do it, so you don't get asked. Number 12?
Number 12.
All right.
Hey.
All right, so this one we have a rectangle, similar idea. Number 12, we have this rectangle. You get 3x minus 8. And then they tell us that the perimeter is equal to 4x minus 12, right? So that means the perimeter is, if I add this side and this side, so I get 3x minus 8. And then I have this side and this side that I don't really know, right? What's that? What did I do? 14. Oh, 14x, thank you. Is it right now? Cool. All right, so if I don't know what this side and these sides are, I can make those both question marks, right? So if I combine this and this, that's going to give me 6x minus 16. And if I subtract those from here, 6x and then add the 16, that's going to get me 8x plus 4. And so between here and here is 8x plus 4. So if they're both the exact same length, how much is each question mark? Well, you basically have to divide it by 2. So you find that you get 4x plus 2 and 4x plus 2. Anything else? We didn't do 13, 14, or 15, so don't stress about those at this time. We good? Cool? Yay? All right. Will you, first, before you pass it up, look at the top right corner of your paper and make sure your name's on it. If it's not, put it on it. And will you pass that forward, please? Yeah, get him?
Yeah.
Okay, cool. I like this one. Cool.
I wasn't there that day.
Yeah, for Tuesday.
Thank you.
Yep.
He looks like the kid from Algebra.
Will you go around and collect the homework?
Yes.
How much? Got
I love you. Good. Friday. Is it here? Yeah, that's all right.
Finally,
We used to buy it red and orange.
you need the homework from me.
No.
I got homework.
Yeah, yeah.
Wait, you don't have a question there?
What?
I got you. You? All right. Perfect. Thank you. Okay. Everyone have the notes? Yes? Let's go to that first page. All right. So now we're going to start multiplying polynomials. And this is really where algebra starts coming together, because our next unit after this is we're going to start undoing the polynomials that we've multiplied together, which is called factoring. And we have a really good way of teaching factoring here. It's very successful with students. But let's start talking about, so let's see, they have us rewind. I don't know why we're rewinding. Oh, okay. So they want us just to combine like terms. So we did this yesterday, right? This type of problem. What did we need to do? Can I drop that set of parentheses right there? Yeah, I have nothing out front that I need to distribute over. And so all those signs stay the same. Is that okay?
Yeah.
But because that's a negative, what do I do?
Distribute.
Yeah, that negative comes here, to here, and here, so it changes all the signs to the right. So if it was a positive, it becomes a negative. If it was negative, it becomes positive. Is that okay so far?
Yeah.
Okay, again, this is just kind of reviewing what we've been working on. So then we want to put it in descending order. So I have 6y to the third. And then I have both of those. So that's just y squared. And combine those, so I get 7y. And combine those, and I get minus 20. And it's done. So that whole thing's in descending order, so it's in standard form. Oh, here. You're awesome. And I clicked the homework, but your name wasn't on here, so as soon as you get it out, just bring it and put it in this folder right here that I have open, if you don't mind. And I think I put a notes on your desk. All right, can I move on?
Yeah.
Cool. All right, so now, first thing, you have to subtract following polynomials, leave your answer in standard form, so descending order with the exponents. Classify your answer by degree and number of terms. So can I just drop the parentheses on this one?
Yes.
Can I drop the parentheses on both sides?
Yes.
Yep, because it's plus, right? So now we need to figure out what's my highest exponent. Right there. Perfect, thanks. So the fourth, good. So I have x to the fourth. So I've used that. And I have that, so that's 3x to the fourth. Okay, are we okay so far? And then I have this term here and this term here. So if I combine those together, I get plus 4x squared. And then it looks like I just have numbers left. Okay, so this is a fourth degree. So it's fourth degree because the highest exponent is fourth. So it's called what? Cubic's third. Quartic? Quartic? And if that's quartic, how many terms do I have? Do I have 1, 2, 3? So it's a quartic what? Trinomial? We'll just call it trino. It's trinomial. You spell it out. Is that okay? It's quartic because it's the highest exponent is 4. Trinomial because we have 3 terms once we combine our like terms. Problem number 2. Looks like I could drop this first set of parentheses without a problem. So we're going to get 2x squared, or third minus x to the fourth plus 10. But that's going to make a difference. Change all those signs. I get that. And then I combine like terms, so it's like, okay, well, I got my x to the fourth, so I have 4x to the fourth. I have my x to the thirds. I have minus 2x squared. And 13. So this is another quartic because it's the fourth power. But I have 4 terms. What is polynomial? Good. So you have monomial for 1 term, binomial for 2 terms, trinomial for 3 terms, and then it becomes polynomial after that. Sound good?
What are you doing on your phone?
Beanie's in his feelings.
Oh, okay.
Oh, are you actually in your feelings?
He always is. That's why he dresses emo. I'm just
What happened? He looks great today. You dressed well.
Yeah, he did actually. Like if he changed his shoes with the
All right.
chains, this would be really good.
You're just a hater.
I don't know what I'm supposed to do here.
7 times 26.
You think that's it?
Yep. Yeah, that's it. And keep
Zip
your
it.
mouth
wait, but he's
Zip
keeping
it.
his mouth shut. There's obviously something about it.
Click.
wrong. How do you tell?
Click the board.
Click the board.
Wait, how do you?
You
They
think there's
actually
something
don't know
here?
what you're supposed to do.
There's nothing on our thing. Well, why do you write it like that?
Because on the other ones, there's also 17.
All right, moving on. And then we have that.
Yeah, and then there's
Wait, how do you actually do this? Someone pull out quick math.
Multiply. And then we have that. I don't know. Okay, I'm not worried about that. I just there was like 19 slides that we don't have to worry about.
One of the teachers just trolled you.
Yeah, you ain't kidding. Like, dude, do this. All right.
Oh, that's why.
So we want to multiply. This is a binomial, and I want to multiply it by a trinomial. So pencils down for a minute just to watch what I'm doing, if that's okay with you. So I'm going to take this, and I'm going to multiply it times this, and this, and this. That's my first step I want to do. Is that okay? So what? 2 times 3 is 6. Is that okay so far? Good. And then x times x to the second, I'm going to add the exponent, so I get x to the third, because that's x to the first. Is that okay so far? So the first part's done. And then notice I have a positive sign here, so I'm going to put a positive sign right here. Is that okay? Now I'm going to go 2x times 2x. 2 times 2 is 4. What do you think x times x is? X squared. Okay, because that's x to the first, x to the first. So I add the exponent, so it becomes x squared. Is that okay so far? And then I'm going to go 2x times negative 4. What's 2x times 4? What's 2 times 4? 8. And then an x comes along. So that's the first part of the problem. Go ahead and copy that part down.
I don't get how you got 3x. Oh.
2 times 3.
I had to get 6x.
2 times 3.
Wait, how'd you get to the third power?
Okay, so x sitting by itself is really to the first power. So if I go x times x, that's x to the first times x to the first. We add the exponents. So 1 plus 1 is 2. In this case, it's x to the first times x to the second. So 1 plus 2 is 3. So that's a great question. So here to here, we just add exponents. Okay? Like bases, you just add the exponents. So just on a really wacky note, we're not going to worry about a problem this big. But let's say I had like x to the 10th times x to the 5th. That becomes x to the 10 plus 5, which is x to the 15. So that's what we're doing now. You're not going to worry about stuff that big, but that's like a weird land type of stuff. Okay. So if you're multiplying, you have like bases. The exponents add. Okay. Are we ready for the next part of this problem?
No, wait, let me write it down.
All right. You ready, Freddie?
Yeah.
Okay. So now I'm going to take negative 5. You still with me? And negative 5 is going to get multiplied by this, and this, and this. Okay? So let's go through. I'll change colors of my pen. Maybe make it red. All right. Be cautious. I have a negative, right? What is negative 5 times 3? Negative 15. and then the x squared comes along for the right. Is that okay so far? I'm pausing, I'm going slow for a reason, because it's kind of a newer concept. Yeah, so then negative 5 times positive 2x is going to be negative 10x. And then the last one, negative 5 times negative 4 is?
20.
Positive 20, right? Because negative times negative? Now just take a look up there. Does that whole string of stuff make sense? Sure. Is there anything that we're missing that I could give you more clarification on?
Can you review the first part maybe?
The first part where I did the 2x times?
Yeah.
Okay, so 2x. So 2x is the same thing as 2x to the first. So are you okay with that? The x has an exponent of 1. So I'm going to go 2 times 3. That's the 6. I think you're okay there.
Yep.
And then x to the first times x to the second. Because I have the same base of x, I add the exponent. So 1 plus 2 is 3. So up there on the very top where I have x to the 10th times x to the 5th, it's not related to this problem. It's just showing you that how you would add your exponents to get like a real big exponent. Whenever you have to use this in life, in geometry and in algebra 2 and pre-calc, college algebra, and that's about it. Yeah.
Are we ever gonna have to divide these?
Not yet.
Like this year.
We will do something called factoring them, but we're not there yet. And factoring is just a way of breaking it back down to the 2 components. But we'll get there. Don't panic. I got a good way of teaching it, I promise you.
Okay.
They didn't have me come here because I have a bad way of teaching them. They left the other guys back at the other school because they're real bad at it. I start yelling kids, what do you mean you don't know how to break 8 up? I don't know. What times what gives me 8? I don't know, 16 times half. No! Well, yeah, that technically does, but you didn't speak clearly enough to the kids.
Yeah.
All right, hey, I think I might have some like terms. Is there any other x to the thirds up there?
No.
No. So bring that down.
Minus 11x.
All right, and then I have this and this. So 4 subtract 15 is how much?
Minus 11.
Minus 11x squared. Good. And notice now when I'm adding and subtracting, my exponents aren't changing at all. So exponents only change when you multiply or divide them.
Minus 18.
And then we're not really dealing with negative. Minus 18x, good. And then what?
Minus 20.
Almost.
I mean, positive 20.
Positive 20, right? So look at that. So that is a third degree. So it is a cubic polynomial, right? But we don't have to necessarily worry about that unless they ask for it. May I move forward?
Yes.
Hi. Joy, you good? All right. All right, so the big idea. So combining like terms and then combining exponents. So combining like terms is like 3x plus 2x. That gives me 5x. That's just combining like terms. Combining exponents is if I go like 3x times 2x, then I get 6x squared. So the exponent increases. Okay, so that's kind of the thought that we're doing. May we move forward? And those are just 2 examples. I mean, there's infinite examples we can pick up, but I just picked those 2 for now. Good? Yeah. Okay. All right, so now we're going to practice the distributive property. So I'll do it in 2 different colors. So the first one, I'm going to multiply x times here and x times there. So x times x, what do you think x times x is? X squared. Is that okay? And then what's x times 5?
X5.
So x5 or 5x, right? And then we'll do this in red. So I have the negative, so negative here and here. So what's negative 2 times x? Negative 2x, good. And what's negative 2 times 5?
Negative 10.
Negative 10. Are there any like terms that are up there?
Yes.
Which ones?
X.
5x.
The 5x and the negative 2x. So 5x subtract 2x is 3x minus 10. That's it. So we're just distributing twice. Common Core calls it double distribute. Everyone else in the world calls it FOIL for first, outer, inner, last. What's the right way to do it? You pick. Where are you going? Why?
Well, you never call anyone else out.
I'm just giving you a hard time. She like started getting angry with me there.
Once she was about to sit down, I was about to go. Just make me mad.
Hey, may I move on?
Yeah.
So for problem number 2, I just have a singleton term that I'm multiplying. I'm going to just multiply everything by 2x. Is that okay? Alright, so I'm going to go 2x times 3x to the second. That's got to be 6x to the third. Are you okay with that? And then I have 2x times negative 4x is negative 8x squared. And then plus 12x. No more like terms there. It's already taken care of. Is that okay? Do you see where the exponents, why they increased? Because x is the same thing as x to the first. When I'm multiplying bases together, you add the exponents. You seen this before? Have you seen this before?
Yes.
All right.
In Mexico.
All right. What part?
What?
What part of Mexico?
Jalisco.
I used to go to Puerto Penasco. Puerto Penasco. So Mexico.
Oh yeah.
Right?
In the middle.
So Puerto Penasco is right here.
Oh yeah.
So this is Agua. Okay.
Yeah.
Sea of Cortez, right? Isn't that the Sea of Cortez? So we used to go to Puerto Penasco. But then we used to go down to Guaymas, down here. And they had great shrimp. Oh, they have good shrimp.
So the food on the coast?
On the coast. On the inside coast, yeah.
I am from Mexico, from Jalisco, in the middle.
About there. Down or top?
Tejas,
Tejas, right here?
I am from Guadalajara.
Guadalajara?
Yeah.
Okay, I know you're at.
Mariachi,
Mhm.
tequila.
Mariachi and tequila. I love it. Alright. Let's see. Problem number 3. We have 2 things to distribute over the parentheses. I'm going to distribute 2x over the parentheses first. So that comes here, here, and here. So 2x times 3x squared is 6x to the third. Because that's to the first. Careful. We're increasing the exponents every time we multiply. 2x times negative 4x is negative 8x squared. Right? Because they're both to the first. And then 2x times 6 is 12x. Is that okay? Then the next one, I'm going to make sure I distribute negative 3 here, and here, and here. So negative 3 times 3x squared is negative 9x squared. And negative 3 times negative 4x is positive 12x. And negative 3 times 6 is negative 18. Do we have any like terms?
Yeah.
So this stands alone, right? And then I have this and that. So that gives me negative 17x, I think, squared. And then I have 12x and 12x, that's 24x. And then minus 18. So this whole thing is my answer here. What do you think?
Number 4.
Yeah, number 4 looks a little goofy, huh? Oh, okay. Dang. Where are we? All right. Okay. Can I move on? Ready for number 4? So number 4, we're distributing 3 things. So let's give ourselves some room. So first one, I'm going to go here, 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 here. That's going to give me 3x to the 4th, right? Minus 4x to the 3rd, plus 6x squared. Is that okay so far? Then let's go to a purple. So I got here, here, and here. So I get plus 6x to the 3rd, minus 8x squared, plus 12x. Am I done, or is there one last thing to do?
There's
One last thing to do. So what should I multiply everything by? Negative 3. Excellent, excellent. So negative 3 right there. So it goes there, and there, and there. So that's going to give me negative 9x squared. Okay. Positive 12x. Great job. And then minus 18. Okay. So now they might be different colors, but we might have like terms. So what's my highest exponent up there?
4.
4. So if I have 3x to the 4th, I don't have any others up there, do I? So I have 3x to the 4th. Okay, so I took care of that.
4x and 6x to the 3rd.
Yeah, so those look like they're going to combine this one and this one. So that gives me plus 2x to the 3rd. So I'm just going to cross them off as I use them. Is that okay? And then what else?
6x to the 7.
How many x squareds do I have? I have 3. I have this one, and then this one as well. So 6 minus 8 is negative 2. Negative 2 minus 9 is negative 11x squared. Cool. So let's cross that, and that off. Then I have 12x and 12x. That's 24x. Yay! And then minus 18. Oh my goodness, that is big. That's a lot there. Woo! Gotta take a nap after that one. We good? Everyone happy? Anyone going out of town for the 3-day weekend?
No, but I know someone who is.
Are you going to attend this or
Nah. Tomorrow we're gonna go see the Avalanche game. My father-in-law likes taking us to one Avalanche game a year. So being it's hockey, I think it's kind of cool. I'll go hang out with him.
And the Avalanche are pretty good, yeah.
He always likes getting nice tickets for us. So
Well, what were we playing?
that I don't know. All I know
If we're
is
playing the Blackhawks, then it's a good game to go because Blackhawks suck. And they just get shut out every time.
we got center ice club level. I don't know what side. That's all I know. My father-in-law insists on it. Gotta sit center ice. Okay, you're paying for it. But it's nice fun. All right. So let's see. See if you can follow what I do here. You follow?
Yeah.
Some of you that might be looking at it going, wait, I'm not seeing it. It's this and this, this and this, this and this, this and this. That's all I did. You good back, Emily? All right. See if you can follow on this one as well. Let's see. That gives me this. So all I did was this times this, and this times this, as well as this and this, and this and this. That's all I did. So you guys want to hear something kind of fun?
Yeah.
You all know that I sing for a teacher band that we have here, right?
No. What?
So we are performing at the talent show and the assembly this year. So we are opening both of them, the talent show and the assembly. First song we're opening with is "We Will Rock You" by Queen, and I will have people involved where stomp, stomp, clap, and then Mr. Peterson is the math teacher, plays drums, so he's going boom, 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 boom. And then I'm gonna get some more people with drums going boom, boom.
Or Radio Gaga when they do the.
Yeah, I'm not doing Radio Gaga, I'm just doing "We Will Rock You."
Let's do all Queen.
All Queen. And then after that, and I don't know when the show will have the second song, but we are doing Soul Man, which is a Blues Brothers song. So should be pretty fun.
So should we come or something?
I would, yes.
Wait,
I don't like performing to an empty gym. I want to perform to 3,000 years, 3,000 plus years.
The assembly, is that like where, like during school when kids are supposed
Yeah, so we'll go to first and second period, then you go to the assembly, and then you go to third period after the assembly.
When is that going to be, like the month?
February 7th, which is a Thursday,
April's coming
is the talent show. So I'll be at night in the theater, and it's a fundraiser week for our Power Week, we call it. So we raise money for Bags of Fun. Bags of Fun are basically like a backpack that's full of like goodies and stuff for kids that are in the hospital for long periods of time. It's a good cause.
I think chocolate's good for kids in the hospital.
It's not chocolate. It's like crayons and for like little kids, not like some 17-year-old. It'd be like coloring books and maybe the latest little toys that might be out. I don't know what little toys little kids play with. My kids don't play with toys anymore. Well, my youngest is a freshman and my oldest is a junior.
What school do they go to?
Arapahoe.
Ew.
Why?
Are they
Wow.
Ew.
Why?
Why? Because I live like from me to you away from Arapahoe.
But then you could just take your kids from school.
So their dad would love that.
Is the
But
school
do you want to go to school where your dad's at?
No.
Well, Mr. Peterson's son goes here.
Huh?
But he's going to school with him.
Dean Weber's son is here.
I know. I agree with you.
Like they don't have to teach her.
Well, my oldest drives, so.
There's literally no one here. There's so many people.
I know. I've tried conveying this argument all along. I can't win.
Yeah, and you just have to save the school so you don't have to.
That is, I'm sorry.
You must
but,
have to drive home.
I know. I really want to have my kids at school here with me because I'm not dad. But Dad, we love you, but we want to be at a different school. It's okay.
Well, how
And they
close
would
is
lose all the
Arapahoe
friends they
compared
have,
to
so.
Creek?
Huh?
They'd have to make new friends.
From your house, how close is Arapahoe?
How many times have you been?
Do what?
From your house, how close is Arapahoe?
Quarter mile. So from here to the east building.
Oh, it's close.
Moves 10 times.
But instead you drive all the way over here.
Why
To
not?
teach you guys, yeah.
Why not?
Totally worth it.
Oh,
Because I brought my medical class here. So I went to the med class. No, I used to teach at Chaparral in Parker.
Ew,
All right. I think this is almost the last problem. What is a times a? What do you think a times a would be? A squared. Very good. And then a times b is ab.
AB squared.
And then multiply that is going to be negative ba or negative ab. And then that's going to give me negative b squared. These are opposite terms. They cancel out. So I'm left with a squared minus b squared. So that's this is actually called the difference of two squares. That's something that we'll get to later. But that's how you do that problem. Now, happy to be here with you guys. Happy they're there. Although I'll show up over there because hey, we have this thing at night. And I'll show up with Creek on. What are you wearing Creek for? I teach there. And then yell every now and then. I'll see the principal. Why are you wearing your Creek stuff here? It's like, I know. I need to speak slower to you.
I teach that.
That's the okay.
Yeah, I bust chops on him. It's funny. All right. Find the area of the triangle. I don't know. I'm kind of done. You guys done?
Yeah.
Okay. All right. So I think we should do this. Page 19 and 20. But I understand it's a 3-day weekend, so why don't we do just the even problems? So that's 2, 4, 6, 8, 10, 12. So that's half the problem. Is that okay?
Yeah.
Cool?
Can I do all of them and get extra credit?
Sure.
Yes.
Could someone turn the lights on for us, please?